On February 15, 2013, a small asteroid, just 17 meters in diameter, which is about the size of a 6-story building, broke up over the city of Chelyabinsk in Russia. The asteroid came as a surprise for both general public and NASA. The agency has been searching for potentially hazardous objects for decades, but the threshold for detection was much higher than the Chelyabinsk asteroid. It was around 140 meters. After Chelyabinsk event, NASA established a Planetary Defense Coordination Office that takes data from the agency's Near-Earth Object Observations Program, analyzes it, and communicates it to the general public. This story shows that it's important to have data, but it's even more important to have timely data. Now that I got your attention, let me introduce myself. My name is Anya Prosvetova. I'm a Tableau visionary and data dev ambassador. And today I'm going to show you how we can use NASA's public API to build an asteroid tracker in Tableau and get timely alerts about future close approaches to Earth. For that, we're going to use the new feature called Table Extensions that is available in Tableau from version 2022.3. Tableau extensions are developed based on the Analytics Extensions framework, so let's look at it first. Analytics extensions allow to build dashboards for viewers to interact with advanced analytical tools that are not available out of the box in Tableau. For example, you can build a dashboard to predict future trends using custom models, where users can test different input scenarios and see the outcome. Or you can also build a dashboard where you can form a sentiment analysis on the text data. Usually when we talk about analytics extensions, the use cases are focused on data science, predictive analytics, or machine learning. Today I want to focus instead on using analytics extension for extracting data from APIs directly in Tableau desktop. At the moment there are two main integrations here, Python and R languages, and my example is using Python language. But everything you see today can be done as well with R language. To use one of these integrations, you'd need to set up a server running TabPy or RServe. These are the frameworks that enable Tableau to run scripts inside your dashboards directly in Tableau desktop. Prior to table extensions that we're going to look at in a moment, you would need to set up a calculated field in your workbook and use one of the script functions to write your script and define the data you want to pass to it. Then you'd need to use TabPy server to send your script and the data, the input data, to Python or R to run this model, run this script, and get back the output data. And then finally, TabPy will send back the output data to Tableau, and you will be able to see it in your dashboard. So that works fine. And in this example that I built before the version 2022.3, where we use script calculations, we can see that in this world map, a user clicks on a country, the name of the country is sent as a parameter of the request to the API, and then the response we get back is additional data points about the country, capital, country area, and the sub-region where the country is located. But if we look at how it is set up in the backend, we can see that for every additional data point that I brought back from the API, I had to create a separate calculated field. So here I created 3 separate calculated fields, one for each data point. So that brings me to some limitations of using script calculations to interact with APIs in Tableau. We get only one data point at a time, so if you need to bring many, that will be quite extensive in terms of the number of calculated fields that you need to create. The script functions in calculated fields, they are a type of a table calculation in Tableau. So any limitations you can think of about related to table calculations, they also will apply here. And also, if you have many calculations running the script every time a user interacts with the dashboard, it can impact in a negative way on the performance of the dashboard. So if you have, for example, 3 calculations, every time a user clicks on the map, these 3 scripts run at the same time to bring you these 3 different data points. And now let's see how table extensions change this approach. So now, instead of creating multiple calculated fields, we can write our script in a way that it returns the complete table with all values that we need to get from an API. And you can use this table that you get back as any other data source in Tableau. And that's why in this case, we are starting our API adventure not on a worksheet in a workbook, but directly on the data sources page in Tableau Desktop. At the moment, you do need to have a starting data set when working with table extensions. You can use it to pass some values to the script as well, but you can also have a dummy table as a starting point if all the logic happens directly in your script. Once you set up connection with the TabPy and you have your input data set, you need to place the script in this window on the right of the screen. Click the Apply button, and then the new data source will be created directly in this window. And then, as I said, you will be able to use it as any data source in Tableau Desktop. There are, of course, as it's a new feature, some limitations currently existing. And for example, the first one is you are not able to dynamically pass parameters from the dashboard into this script to somehow update the table and bring new values. There is a workaround at the moment that if you're using the input data source as if your input data source is a database, you can use a custom SQL to bring the data from this database and then use parameters inside the custom SQL. And then if the user changes the parameters on the dashboard, this will be passed to the script and the script will be updated. And as I mentioned, another limitation is you do have to have some kind of starting point, a starting data set for using the table extensions now, but hopefully this will be eliminated in future. So let's see how it looks like in practice, how using table extensions can help us to create an asteroid tracker in Tableau. And this is the dashboard that I created using the NASA's API. By default, this view shows you the today's date and the close approaches to Earth on that date. I'm recording this session on 11th of December, so you can see that the first date in this list is the 11th of December. And you can see on the x-axis the close approach time to Earth in UTC on the selected date. And then on the y-axis is missed distance in lunar distances. Lunar distances is something that NASA frequently using, and it refers to the average distance between the Earth and the Moon. And approximately it's 384,000 kilometers. And I find it's a little bit easier to relate to and think about the distances between the Earth and the asteroids that are going to be close by, because it just helps you to understand a little bit, imagine the distance a little bit better. You can also flip through the dates of the close approach. So the first one is always today, but then the period is covering the next 7 days from today. That's just a limitation of the API. You can't bring more than 7 days of data in a row. And you can see that the size of the icons referring to individual asteroids are also bigger or smaller depending on their size. The size is set here in meters. And then some of them are colored in red, and that means that these are classified by NASA as potentially hazardous. Like this one, for example, that will appear on the 13th of December somewhere in the evening. And it doesn't mean that this asteroid is going to be potentially hazardous on this day when it will appear, but potentially hazardous asteroids are somehow they have a certain combination of features that NASA sees as potentially hazardous. So if anything changes in future, maybe their orbit or their speed or their direction, they might pose a threat to the planet, but not at the moment. This is just something they need to closely monitor. And we can also see here not only the data for each individual day, but also we can see 5 closest approaches in the next 7 days. So in the period that we are currently looking at, and we can see this table underneath at the bottom of the dashboard. So this is a final dashboard that I built using the table extensions in Tableau. And before I will show you practically how to do this in Tableau Desktop, I just want to walk you through quickly through the script that I have, through the Python script, and show you what it does actually and what's the logic in my script. So first, as always, when we work with Python or any other language really, we need to import the libraries that we're going to use. Then I need to also create a new variable for the API key that you can get from the NASA's website. And then I'm going to set the period for which I would like to see the asteroids, the close approaches. So in this case, as I mentioned, I set the default start date as today. So every time a user opens a dashboard, the script will run and the first date in the dataset will become the date when the dashboard is open, so today. And then the end of the period, again, as I mentioned earlier, the limitation of the API that the period has to be only 7 days. So here it will be today, or rather start date, plus 7 days. Then I'm going to just convert these dates to strings so I can add them to my URL. That is going to be my request that I send to the API, which takes the start date, the end date, and then my API key. So you can see when I run this cell, I do get the URL with the dates. Again, I'm recording it on the 11th of December. So the start date is 11th of December, and then the end date is 18th of December. And that's my API key. And when we work with APIs, it's always good to check first whether your request is structured correctly and whether the API is actually up and running. So when we send the response, we create a variable that gets us the response code, and the response code comes back as 200, which is what we are looking for. 200 means that everything is fine, the API is working, and your request is structured in the right way. And then we get back our response, and response here from the API comes in JSON format, which is quite easy to work with. It's structured, it has the key and value pairs of objects, and we can parse it in a relatively easy way later on. So you can see here the structure of this response is showing us the date of the close approach, and then for each date you have individual objects with all the details about them, their speed, their whether they're potentially hazardous, their missed distance, the diameter, and so on. And so for every object you will have a separate section, and then for new date the structure repeats itself. So now when we see that we get in the response and it's all looking as we expect, then we create a data frame. That's a term in Python that just simply means a table that you have structured with certain columns. So I'm setting the structure here because I don't have this data frame yet. I need to set the structure. I need to say these are the columns that I want to bring back. And then this part of the code is just parsing the different levels of JSON response to get back the variables, the values, the data points that I want to have in Tableau in my table. And then once it parses the JSON, it stores it in this data frame that I created just earlier. And then finally, I have the complete table with all dates that I requested for and all the objects and all the features of this object. And here is an example. This is just top 10 rows from this data set. You can see that it's all nicely structured. We have all the values coming back, we have the dates. And so we now can bring this table back in Tableau. And to bring this in Tableau, you need to structure it as a list, but that's just a special way to bring it back in Tableau. Otherwise, this is final result, and we're quite happy with that. So as you see, as you will see in a second, setting up this in Tableau Desktop is a very easy process, but then the main logic and the most amount of work, the most amount of time you will spend is actually crafting your script and trying to make sure that everything works as you want, and the table comes in the shape and form as you want it to be, and all the data points are there. Now that we understand how the Python script is working and what kind of table we're bringing back, what data points we're bringing back to Tableau, let's see how we can set up the table extensions in Tableau Desktop to bring this data back from Tableau. But also first, we need to check that our TabPy server is up and running. For this demo, I'm using a TabPy server on my local machine. So I will launch it just in my terminal. In production, it's always advised to have a separate server running your TabPy or RServe server. So it's always live, and every time your users access dashboards on Tableau server or Tableau Online that are running some scripts, they will be always to run the scripts correctly and everything will work fine. In my case, as I said, I need to launch it first because it's on my local machine. To launch it, it's very easy. I just type TabPy in my terminal, press enter, and then I get the message web service listening on port 9004. Once you see that, that means that TabPy server is running and you are able to use it in Tableau Desktop. So now let's go to Tableau Desktop. I have a new workbook set up as a starting point. And as you see here, I also have already a starting data set, which is just a simple list of dates. It's a CSV file, and that's what we're going to use as a starting point for our script. But actually, we don't need to have it on the canvas yet. Let's remove it, and let's bring the new table extensions object. Once we bring it here, we see the smaller canvas on the left, the window where we will paste the custom script on the right, and also the information about the current analytics connection. And as you can see, we have the details of our TabPy running on the local machine with the port 9004. If you haven't set up your connection to TabPy yet, you can always do it, or you need to restart it again. You can always do it by going to Help section at the top, go into Settings and Performance section, and then Manage Analytics Extension Connection. And here you will see you can put the details of the host name, port, and if you do have password and username, add these details here as well. Once you're ready, you can click Test Connection to see whether this is all working fine. It is in our case. Click OK, and then I already have it saved. I just have it click Close button. Now that we are ready to run the table extension, we will need to bring back our dates CSV as a starting point, and you will see that it will appear here at the bottom, the input table detail. And now let me make it slightly smaller and maybe close this section, because we are going to focus on the script section. And I will just save some time and paste the script that I showed you earlier. I haven't changed anything. It's exactly the same script that we saw a couple of minutes ago. So now we're all ready to go. Let's click Apply button, and that will trigger TabPy to run this script that we pasted. And now you can see we have the name of our fields appearing in the lower part on the left, and we can go to the Output Table section below the script. Click Update Now. And you can see that these are the fields, these are all the columns that we had originally in our data frame in the Python script. We now have them all in Tableau directly. And if I close this window for table extension, you see this table extension appears as a data source. So you can, for example, join another data source to the table that's coming from the table extension, and use it as any data source in Tableau Desktop. And if I go to the worksheet, I can see all my fields appearing here, and I can just drag them as any other field in Tableau and work with them again in any normal data set in Tableau. So as you can see, it's quite straightforward to set up the table extension in Tableau Desktop. The most difficult part is to obviously write the script and make sure that it works correctly as you expect. So now that we understand practically how it works in Tableau, let's just go back and see at some potential use cases that I thought about when I was working on this demo. First of all, I thought about why not to use internal Tableau APIs that we have to build maybe some kind of monitoring tool that you can use on Tableau Server or Tableau Online. So for example, you can build a data dictionary connecting to Tableau's metadata API. So every time you open this workbook, this dashboard, it will show you all calculated fields that you have. Like I have an example here on the right. You can see the formula that's used, the data type, what workbook or dashboard this I used, and you can filter by certain project or certain workbook and dashboard. So that can be quite a nice use case. You can also use this feature to build small tracking dashboards or automate certain notifications. So if you have APIs that serve just purely the purpose of telling you the statuses or how the connection between different parts of your pipeline is working, or some kind of internal API maybe that monitors certain technology in your company, you can use this very easily, build these tracking dashboards and have the custom notifications set up. And that will eliminate the need to build a custom web data connector. You can just use the table extensions for these purposes, and that will be much easier. Of course, if you're going to bring a lot of data from an API, you have to have it live and constantly updated. I would recommend going the route that it's currently used to get the data from an API first, build the published data source, and then use it in Tableau just to make your dashboards more performant. But at the same time, you can still use table extensions in that case as a way to build a proof of concept and see how the data should be modeled. What data do you actually need to bring from the API to work with a subset of this? And then once you're happy with it, you can put it in production and have it properly running outside Tableau. And that's all from me today, but I obviously wanted to share some useful resources if you want to dig deeper and learn more about different use cases and the settings and the configurations for TabPy specifically. But also there are a couple of really nice articles from Tableau about how to use analytics extensions for data science in Tableau. And there are a couple of videos from Tim and from Amir specifically about the feature of table extensions that came out recently, and they also have quite a lot of interesting examples and use cases there. And if you want to learn more about Tableau's APIs or just extending the Tableau capabilities, automating process in Tableau, I would highly recommend you to join Tableau Developer Program, where you can get access to a great community, but also access to your personal Tableau Online sandbox where you can play around with these APIs and learn how to use this in your everyday work. Thank you for joining me today. I hope you enjoyed this and found the session useful and now have a lot of ideas of how to implement it in your project. If you want to have access to the slides, to my code and the workbook that I was showing with the tracker, feel free to scan the QR code and that will take you to the GitHub repository with all the materials from the session. If you do have any questions, please reach out. Otherwise, enjoy your day and other sessions. Thank you.